Okay, anyhow I explained the அவனோட friend யாராவது இருந்தா கேட்டு அவனுக்கு சொல்லி கொடுத்துருங்க. So in DPCM, so for each sample we transmitted n number of bits. Okay, and there is a redundancy. So here the signal won't vary much. So if you convert your samples into binary sequence, you will get the same binary sequence. Okay. So to overcome that, we are going for delta modulation. In delta modulation, so you are going to transmit only 1 bit per sample. Okay. So whereas in DPCM, we will transmit n number of sequence. So to reduce the number of bits and redundancy, we are going for delta modulation. Right. So here I will give some example. So first I'm going to take, it is some value 2.3. Let me take 2.3. So how we are going to transmit in delta modulation? So first I'm going to take 2.3. So first initially we assume it is 0 and we are analyzing it. So 2.3. So some comparator will find the difference between these two. So 2.3 minus 0. So here you will get 2.3. So it is positive value. Okay. So you are going to round off to the 1 bit. You are going to round off to 1 bit. So it is, you are going to get 2 here. Okay, so 2 is positive. So sign of EQ of NTS is positive. So in that case, you are going to transmit 1. Okay, so first you are going to transmit 1. So first we assume pannadhu vandu 0 nu assume pannom. Then we transmitted. Right. So next case. So next sample I am going to assume it is 4.5. Okay, first 2.3 I taken, then 4.5 I taken. So here if you see, so here the value is 2, here the value is 1. We assume it as x cap of NTS, we assume it as 0. Okay, so here you will get 2. So here you are going to delay it by TS. So one shift munadi varum. So idukku previous ana enna sample iruko, we have to take that one. So previous sample is 0. So second one the 2 vandhudu. So now, so here after delay, so idu enna eludum, u of n minus 1 into ts nu eludva. Right. So idoda previous value. So here it is 2, u of NTS is 2. So u of n minus 1 into ts is 0. So again here 0. So 4.5 minus 0. Here you will get 4.5. So if you round off to the nearest value, you will get 5. Okay, I assume it is 5. Okay, so 5. So it is positive value. So here 1. Again I'm going to transmit 1. Okay, so now here it is 5. So already in u of n minus 1 into ts is 0 then I'm assume pannom. Right, so 0 plus 5. So here again you will get 5 here. So what is u of n minus 1 into ts? So next sample is 5. Next value is 5. So the previous value 2. So now it is 2 here. Okay, so next I'm going to take it as 5.3. Okay. So find the comparator will find the difference 5.3 minus 2. So you will get 3.3. So the next value is 3.3. So if you round off to the nearest value, it is 3. So again it is positive value. So here 1. Okay. So now here it is 3. Here you will get 2. So the previous value we taken as 2. Okay. So here it is 2. So 2 plus 3 again 5. Okay, so the u of n minus 1 into ts, here it is 5. Okay, so 5. So our next value I'm going to take it as 6.2. So assume like that. Okay, so thereby you're going to this process will continuous and you're going to find the value and you're going to, so இங்க வந்து இங்க reduce ஆக ஆரம்பிச்சிருச்சு. இந்த value x cap of n is it starts to increase. So next இது வரும்போது it starts to increase. 7 வந்துரும். So 7 வரும்போது obviously you will get the higher value. So this value will starts to reduce. So negative ல வந்துரும். So in that case, so உன்னோட analog signal எப்படி இருக்கு? So first it will starts to increase and it starts to decrease. So it increase ஆகிற வரைக்கும், so you will get positive values. Okay. So after that it starts to reduce. So in that case you will get the negative value. So in that time you will going to transmit 0 0 0. Okay. So இங்க வந்து delta modulationல so 1 1 1 அப்படினா, so the step size is uniform. You're going to use the same step size. You're not going to vary the step size of your signal. Okay, so here uniform. Okay. So this is delta modulation. So DPCM la, so instead of 1 க்கு பதிலா இங்க 2 இருந்ததுனா you are going to transmit with n number of sequence. So you are not going to use 1 and 0. So you are going to use n bits there in DPCM. Any doubt in this? Yes. Whether you people are there?
Yes, ma'am.
So next one in, so same thing here. First enakku 111 vanduchu, right? So in example, the example which we taken, that you got 111. Okay, so first adha vechu na solli tharan. So when it is 111, so first here you're going to take it as 0. Same thing. So here it is 1 plus, so here it is value is 1. So 1 plus 0, again 1 here. Okay, so first it will generate the quantized output. So 1 you will get here. Okay, so you're going to fed this low pass filter. You're going to fed this quantized output to the low pass filter. So low pass filter enna panuna, so it will take only the, it will smoothen your signal. Quantized output, it will smoothen it and it will generate a smooth analog signal like this. Okay, so it will filter the remaining part. It will idu mattum eduthukom. So this part only it will take and it will generate a smooth analog signal. So on the quantized output vandu, so on the staircase mari irukum illaya, so it will smoothen that filter, smoothen the signal and it will generate a analog signal. Okay, so first adhe da, so here you will get 1. So initially you will get 1. So 1 will come here. So inga delay ஆகும்போது, so again here it will 0. So previous வந்து 0 தான் எடுத்திருக்கோம். So 0. So again next input, it will take the next input, that is binary sequence. So next is 1. So 1 plus 0. So again 1. So it will increase by 1. Okay, so the same 1 will come here. So inge vandu ipa delay by 1 time period, you will get again, you will get 1 here. You will get 1 here. So next bit is 1. 1 plus 1, 2. Okay, so here you will get 2. So inge vandu step size increase ana, it won't the amplitude increase, it won't increase the step size. Okay, so same unit step size will follow here. Okay, so just it increase or decrease and பார்க்கும். So if it is in positive or it is in negative. So if it is positive, it will increase. If it is negative, it will decrease. Okay, so this is your receiver part of your delta modulation. So either adaptive delta modulation, to vary your step size, we are moving for adaptive delta modulation. Okay, so yeah, adaptive delta modulation porana, there is two drawbacks. One is slope overload distortion and granular noise. So when the input signal varies, it varies, your step size won't vary. Okay, so it's the same fixed step size we are going to follow. So in that case, if you find the difference between the input signal and the quantized output, that is a staircase waveform, so there will be a lot of difference. Okay, so that's slope overload distortion solvanga. Right, so actually your signal is steeply increasing, but the quantized output won't increase same as your, it won't increase same as your input signal. So in that case, there will be difference between your input and the quantized output. Okay, so that error is called as slope overload distortion. Okay, so if you want to overcome this, what you have to do, you have to increase your step size. You should not follow the fixed step size. So you have to increase the step size based on your input signal. So next one is granular noise. Now, so here the input won't vary, but the step size is varying. Okay, actually inga vandu constant ah irukano. So but yeah, you're having some fixed step size. Okay, so if you here also, if you find the difference between the input and the quantized output, there will be some error, there will be some difference. Okay, நம்ம இன்புட் சிக்னல் என்ன கொடுத்துருக்கோமோ அப்ராக்சிமேட்லி உன்னோட அவுட்புட் சிக்னலும் அதே மாதிரி இருக்கணும், குவான்டைஸ் பண்ண படமும் அதே மாதிரி இருக்கணும், more or less, not exactly, more or less it should be same. So but here it very much actually constant ah irukku. So but here it is varying, the step size is varying. Okay, so if you find the difference between these two, there will be some error. That error is called as granular noise. So adukku enna pananum appadina, so input signal kammiya irukumbodhu you have to reduce the step size. Okay, for that only we are going for adaptive delta modulation. Adaptive nale namakku name you have to, you are going to adapt for the input signal. Okay, input signal vary aga unoda output you are going to vary it, you are going to adapt for that. Okay, that is adaptive delta modulation. So ingeyum adhe da follow agum. So here if you see same thing, here 2.3 nu irukku. First we assume it is same thing. I'm going to take it as example. So 2.3, first initially we consider it as 0. So here the difference is 2.3 you will get. Okay, so here you will get, if you round off you will get 2. Okay, so here it will check how much it increases. Okay, how much it increases, it is 2. Okay, so it will increase the step size by 2. So this value is given to step size controller. So logic for that is, it will control your step size. Okay, it will vary your step size based on your amplitude which we are getting here. Okay, so 3 now, so it will again, it will vary by 3. So it will send that value to 1-bit quantizer. Again it will vary the step to 2. So முதல்ல எப்படி இருந்ததுன்னா ஒரே ஒரு ஸ்டெப் மட்டும் இன்க்ரீஸ் ஆகும். whereas so here if it is value vary ஆக based on that